So in this video we are going to obfuscate the import strings in the exe file. So malware analyst will use these PE-bear and other tools to do the static analysis. So in this static analysis the malware analyst won't run the binary file. Instead he uses tools to get the information as much as possible to understand what the program is doing. So if I am the malware analyst, I will open this in PE-bear and of course sees the imports, what the import DLL and the functions it's the exe is using. So if I open in the normal PE viewer, I can see there is a kernel 32.dll, and here we have the two functions, virtual dialog and exit process. As soon as I see the virtual dialog, so something fishy is going on, because it's allocating some memory and exiting. So you will also have other functions. If you wrote, this is Metasploit generator one, if you have written normally, you will have much more functions like create remote thread, etc. So as soon as the malware analyst sees the create remote thread and all these flaggable functions, so he immediately understands that this is malware. So instead of these actual strings, we can obfuscate this. We can use Caesar cipher for this. So Caesar cipher is a simple one. So I have already wrote the code. It's very simple. So here we have seen these parsing the imports in the previous video. Now we are just printing out the DLL name, and also we are going to use the obfuscate function. So in this obfuscate function we will use the key as 1 for now, so to get the simple understanding. So if I go to obfuscate function, it takes the plain string and the key. So the key is the shift 1. We have uppercase characters, lowercase characters. So you can also take the ASCII code of the character and you can add that key. But this is my way of doing this Caesar cipher. So what we are going to do is, if the string is ABCD, now the shift is 1. So what we are going to do is, we are going to find the index of this capital A in this array, so which is 0, and I am going to add this shift to this index. Now if I add +1 to this, I will get the value 1. Now I go and fetch the element at this index in the same uppercase array. So uppercase of 1 gives you B. So that means the capital B is my new string, new character. So I'm going to append that one. So same thing applies to the other characters in the string as well. You take B and find the index in this uppercase character. If you found any index, so that means the index is 1, you going to add the shift to this, you get 2, and uppercase of 2 gives you C. So C is the new character. So in this way this Caesar cipher works. So we are just looping over the source string, and we are checking if the uppercase is equals to matches this one, and we are putting a flag is present true, and then we are just using this index, and index should be reminder operator, modulo operator with this length, because it should not overgo about the uppercase dot length. In the same way to the lowercase characters, and if there is a number which is not present in these arrays, so we are just appending that number to this obfuscated string. So we will get some Caesar ciphered string, and we are going to replace that old string, that is kernel32.dll, with the new string, that is the obfuscated ciphered text. So what we are going to do is, we are going to search from each byte up to this length. So we are searching from starting to ending, and then we are going to get string for each bytes, and then we are comparing with this old string. If this is equal, then that means we are going to modify the bytes at that old string with the new string. So we are modifying each character with the new string, that is our ciphered text. So that's it. That's what this function does. It's gonna create a new binary that is called character3.exe. So let's run this one. So character2.exe, and now this function gonna create a new binary character3.exe. So let's go and run this. So it's gonna parse the imports. So let's exit and let's open that character3.exe. So let's go to imports, and here we can see the some random character string, but here when you see 32 you will probably guess that it might be DLL, but you don't know the functions. So it's very easy to decipher. So if you since the key is 1, you can backtrack one character. So the previous character for L is K, and for F it's E, and S it's R. So similar to like the KER NEL 32.DLL. So we gonna get the DLL. And in the same way for these functions as well, if you're gonna backtrack one before, so the character before W is V and I J R S, so we get virtual allow. So in this way, when malware analyst sees, so this not gonna stop malware analyst from figuring out this one, but it's gonna delay malware analyst for sure. So we can use other transposition ciphers as well. So let's decode this one. So let's say character3.exe. So what we're going to do is whenever you parse this string, all you need to do is you need to call this deobfuscate, which probably deciphers with the key. So we are just calling the deobfuscate function with the key which we are given to the obfuscate function. So DLL name, so we can also deobfuscate this. Now after deobfuscating, we can copy the same the deobfuscated names to these addresses as well. So if you run this, so here we can see the deobfuscated, deciphered DLL and the function names. So after deobfuscation, we can write to this process memory. So we have parsed all of this in this process memory, so we can write this updated names to that memory, and you can parse the base location and execute the code. So that's all for this video. It's a simple trick, but it still delays the malware analyst for the static analysis.